Hey Dr. Lane, so I'm doing a reassessment for chapter 15 and I picked a problem you kind of gave us in class as a practice question, but we didn't really finish it, and it says a small ball is an insulating material, each of whose molecules polarizes partial to the applied electric field, QS equals alpha E applied, where alpha is a constant. If there is n molecules in the ball and it has no excess charge, calculate the force that the neutral ball exerts on a point charge q, a distance x away. So I drew a picture here of what that would look like, and the polarization would equal, just like you gave us, QS equals E applied, and the QS is from the dipole equation, which I got right there, and E applied would be 1 over the constant, 9 times 10 to the negative 9th, and then a bunch of units, times q over x squared, which would be the radius, but in this case it would be r in our case, times r hat. And r hat here, if we were to calculate it using numbers and everything, it would just be divided, like the radius divided by the magnitude, and it'd be divided by itself, so it'd just be 1, so it wouldn't really affect it, so we don't really need to put it anywhere else. So QS is alpha E applied, which we just have alpha E applied. We have E applied right there. So we can just plug into this kind of big equation. So we get 1 over 4 pi E naught, and then we have a big parentheses, 2 times, and then alpha, and then once again 1 over 4 pi E naught times Q over X squared, close that parentheses, times Q. And we get that from mixing these two equations right here, this one and this one, all over x cubed. So the things that cancel are just two constants. So our force would be 2 pi q squared over x to the 5th. So that would be the polarization, I guess, that dipole would inflict on from point A to inflict on point B. Thank you.